Hello friends, in this video, you will learn how you can create and import your own hairstyle for a MetaHuman. I will show all the steps one by one, starting with importing a MetaHuman into Unreal Engine. In previous videos, I have already shown how to create a custom MetaHuman in the MetaHuman Creator online portal. In this video, we will import your custom MetaHuman or an already prepared one offered by Quixel Bridge. So, we launch Unreal Engine. When opening, we see a window where we can either select a previously created project or create a new one. Let's create a new one so that everything is clear and created from the first step. We select Games and a blank scene. In Project Details, for those who do not want to create scripts in C++, we choose Blueprint. The target platform I select is Desktop. The quality presets, I set it to Maximum, because in this video, my ultimate goal for creating a MetaHuman is to produce high-quality animation in Unreal Engine. I don't need the starter kit in this case. I check that I have selected the correct project location and name the project Groom Tutorial. Then, I press the Create button and wait for Unreal Engine to launch. Now we need to import our MetaHuman into Unreal Engine. To do this, we go to the top menu in Window and find Quixel Bridge. Oh, here again are some updates and changes. We are asked to log into our account. We enter our email and password. So, what does it say here? As we can see, MetaHuman is still in Quixel Bridge, so we press the Stay Here button. We select the MetaHuman tab, but we only see standard MetaHumans and not our custom one. Apparently, we are still not logged into our account. We press Login again in the profile. Now I see the My MetaHumans tab. I will show how to import your hair using the example of the MetaHuman Oscar. I select him. As I can see, the import button is inactive, even though I had already downloaded him earlier. This is because I set his quality to Cinematics, so in the Quality tab, I select Cinematics. Now the Add button is activated. I press it. And now I see a new folder, MetaHumans. I go into it and see the Oscar folder, which contains the Oscar blueprint. This is the MetaHuman. I double-click on it to open it. In order for the MetaHuman to work, additional plugins need to be activated in Unreal Engine, which is why these windows appear. All I need to do is press the Enable Missing button. I press Enable Missing on all the prompts. Then we are asked to restart Unreal Engine to activate them. I press Restart now. Unreal Engine restarts. And now I can drag the Oscar blueprint into the scene. Here is our custom MetaHuman, which I created in MetaHuman Creator. We can see how LODs switch. This is very useful for games where real-time animation is needed. But for me, quality is much more important since I mainly use MetaHuman for creating video animation. So, I want to disable the LOD switching function so that the MetaHuman always uses LOD 0, which is the highest quality LOD. To do this, I double-click on the Oscar blueprint and open it. On the left, I find LOD System and Details. I set all LOD values to 0. Then I compile the blueprint. Now I need to export the head to Maya in order to create custom hair there. Let's briefly examine the structure of a MetaHuman. On the left, we see all its components. For example, we see the skeletal mesh body. We can see which model belongs to it and which material is assigned. Then there are the feet. These are the shoes. Next, the legs. These are the jeans. All these parts are loaded separately but are controlled by the same controllers. Finally, the torso. This is the sweater. We are interested in the head, which is in the face section. We select the head and click on the Find Source icon. This immediately opens the path where the head is stored. We right-click on it. Select Asset Actions. Then Export. We find the folder on our hard drive where we want to save it and click Save. Then simply press the Export button. Now, let's move to Maya. In Maya, we need to import the head. We locate the previously saved head model. In the FBX file content settings, I choose Add and Update Animation, and in the current preset, I select Autodesk Media and Entertainment. Then, I click Import. Here is Oscar's head from Unreal Engine. We only need the model of the default facial expression with the highest polygon count. Everything else is unnecessary. We select this model. In the rigging interface, we go to Skin and choose Unbind Skin. Then, we delete all the other models. As well as the skeleton itself, since we don't need it either. Now, let's check whether the position and scale of the head remain unchanged if we export it back to Unreal Engine. I export the model as an FBX file. In Unreal Engine, I create a new folder where I will store all the files related to this tutorial. Then, I import the head model and simply press Import with the default settings. Next, I open Oscar's blueprint and drag the imported head model into the hierarchy window. Yes, the head model is positioned exactly as before. Now, we can create our hairstyle, knowing that its position will perfectly align with Oscar's original head. I now delete the imported head model and its materials since we no longer need them. I save the project and return to Maya. I'm not a big fan of working with triangles, and we don't need the entire head. So, I decide to quickly create my own polygonal cap on Oscar's head, which I will use for the hair. I select the head model and switch it to live mode. Then, I select the quad draw tool to create the topology. I distribute the points. If you are not satisfied with the placement of any element, whether it's a point or a polygon, you can delete them using Ctrl+Shift while clicking on the element with the left mouse button. I distribute them at a fairly large distance. I can increase the level of detail later. Next, while holding Shift, I create polygons between the points, adding new points and polygons as needed. When everything is ready, I hold Shift to smooth the model, distributing it evenly around Oscar's head. I don't like this triangle. I can replace it with quadrilateral polygons. By holding Ctrl, you can add new edges, splitting polygons and increasing detail. But in this case, it's easier for me to apply a smooth modifier to the entire cap model, which instantly increases the level of detail. Now, the cap model has shrunk. To reposition it correctly on Oscar's head again, I can use this trick. By pressing the Beat key, I increase the size of the soft selection brush to a very large area. Now, when I move any point, all points affected by soft selection will automatically snap to Oscar's head surface, since we have Live mode enabled. As you can see, the cap is now back on the surface. I will add another smooth modifier and do the same, further increasing the level of detail. I adjust the cap, and with the help of soft selection, I can easily change its shape if I made a mistake somewhere. Next, I need to slightly sink the cap into Oscar's head so that our hair grows directly from the scalp and does not float in the air. To do this, I select the cap's polygons, take the Move tool, and while holding the Control key and the middle mouse button, move it in the viewport. This creates an inflate effect. The cap is now ready. I place Oscar's head into a layer to prevent accidentally selecting it, as I will be working with the cap. Now, we need to create the UV layout for the cap. This is very important for generating hair with XGen. First, I apply a planar UV projection along the y-axis. Then, I go to the UV editor and use the unfold function to unwrap the UV coordinates. Next, I adjust the layout to fit within the UV boundaries and, if possible, rotate it to make the UV map symmetrical. This will make hair creation easier, especially if you plan to make a symmetrical hairstyle. Now, let's start creating the hair. I plan to make something very simple since the goal of this tutorial is not hair creation but rather how to import it into Unreal Engine. So, I will create a mohawk. First, if your XGen plugin is not activated, you need to enable it. Go to the Windows menu, then Settings and Preferences, and select Plugins. Find the XGen plugin and activate it. Sometimes, even when activated, it does not work for me. As you can see, in the Generate menu, I don't see the Interactive Groom editor. However, by clicking Open XGen window, it activates automatically. Now I can open the Interactive Groom editor. Next, make sure the cap is selected. Then, go to Create Interactive Groom Splines. I leave all settings as default and click Create. The hair appears gray because the standard viewport material is enabled. Let's disable it. In the description settings, you can adjust the hair thickness, as well as tapering towards the ends. Now, let's add the guide modifier. Click on the guide modifier and then press the Create button. This will generate many unorganized guides. In the Guides section, find the Sculpt layer and activate it. Pay close attention, this is very important. Do not confuse it with the Sculpt layer for hair. This is the Sculpt layer specifically for guides. To create custom and organized guides, we need to select in Guide Base. Then, in the Attribute Editor, select the Density brush. In the Density brush attributes, choose Decrease. Now, locate the Flood button and press it several times. This way, we erase all guides. Now, to create our guides, we need to select the place brush. Enable symmetry along the x-axis and paint the guides. They are a bit short, so we need to increase their length. Let's set the initial length to 5. Then, I apply the guides to create a mohawk hairstyle. It looks great, but we need to remove some extra hair. To do this, I go to Description Base and click Load Texture in the Density Mask attributes. You can paint your density texture, but since this lesson is not about hair creation, I will choose the fastest way to get results. So, I select Ramp and set the interpolation to None. This allows for a sharp transition from black, where there will be no hair, to white, where hair will grow. However, the ramp type is aligned along the V-axis, which does not fit our UV layout. Therefore, we switch the type to U-ramp. Now everything is fine, and we can easily adjust the hair growth area. I think it looks good. To make navigation easier, I assign a standard material to the main head. I also need to set Viewport Render Light Intensity to 1. Now it looks better. Since the sculpt layer in the guides is active, we can start modifying the hairstyle. I select the comb brush, enable symmetry along the x-axis, and begin adjusting the hairstyle. I also use the length brush to change the hair length. The effect is too strong, so I reduce its intensity in the length brush settings by decreasing the strength. Now it's good. I adjust the length and modify the hair shape. Let's increase the length a bit more and refine the shape. Now, you can see that the hair is not smooth. It appears to have breaks. To fix this and make it smoother, go to Description Base and increase the CV count to a higher number. For example, 25. Then click Rebuild. Now our hair looks more realistic. I also want to align the hair boundary. To do this, we need to assign a sculpt layer to the hair. Click Add Modifier and select Sculpt. To increase realism, let's also add some noise. Click Add Modifier, then select Noise. Adjust the noise settings by lowering the frequency and refining its distribution along the hair length. Now, we will align the hair boundary. It is crucial to have the sculpt layer active for the hair, not for the guides. Select the cut brush, enable x-axis symmetry again, and trim the hair to align its boundary. Perfect. However, you can see that the hair tips now look cut off. To fix this, we need to rebuild the hair again. Go to Description Base and click Rebuild. Excellent. Let's tweak the guides a bit more. It looks strange when hair grows on the forehead. I think it's better to remove those hairs. To do this, add another ramp to the density mask slot. Again, set interpolation to none and adjust the color positions in the ramp. However, this time, adjust it along the V-axis. Perfect. Now, let's further refine the guides. I think we need to increase the hair density. In the description base settings, I increase the density multiplier. I also adjust the hair thickness, setting the final value to 0.15. Let's also add a clump modifier. This should be enough for testing. The only thing I don't like is one stray hair in the front. So, I change the seed value to redistribute the clump modifier differently. I also think the hair should be denser. Now it looks fine. This hairstyle will be transferred to our MetaHuman. I save the scene. Now, to transfer the hair, we need to perform specific actions. The hair must be baked. To do this, we duplicate our cap model and name it Cap Export Groom. Then, I select this model. I select Description, next, go to Description, and temporarily disable it to show that after the next steps, we will get new hair instead of the ones we created. And click Transfer. We now have a new description, ready for export, without guides and other modifiers. I rename the new hair to Groom Export. Then, go to Description, Cache, Export Cache. Important settings. In Cache Time Range, select Current Range. Enable Multiple Transform and write Final Width. Choose the appropriate folder and name the Alembic cache file. Click Export. Now we are done with Maya. Let's move to Unreal Engine. To be able to import Groom into Unreal Engine, we need to activate the corresponding plugin. To do this, we go to the menu, Edit, Plugins. In the search field, we type Groom and activate the Alembic Groom Importer plugin. After that, we need to restart Unreal Engine. Now we need to import our Groom. First, double-click to open the Oscar level. We go to our Groom tutorial folder and click Import. We select the Alembic file of the hair that we created in Maya and click Open. A window opens where we need to select the hair orientation. Since Maya and Unreal Engine have different coordinate systems, we need to set the rotation to -90 on the x-axis and 180 degrees on the z-axis. Then we click Import. Now the hair is correctly oriented. Next, to attach the hair to Oscar's head, we need to create a binding to his head. For this, right-click on the imported Groom and choose Create Binding. In the opened window, in the Target Skeletal Mesh tab, we find Oscar's head and click Create. Now we can simply close the next opened window. Now we have everything needed to attach the new hairstyle to Oscar's head. We open the blueprint for the MetaHuman Oscar. First, we need to erase or hide Oscar's hair, which belongs to MetaHuman. I prefer to hide it in case I want to change his hairstyle in the future. To do this, on the left, in the head hierarchy, you can see many different grooms attached to it. There are eyelashes, eyebrows, and beard. We find the groom hair and select it. Then, on the right in the properties, in the search bar, we type visibility and uncheck the visibility checkbox. The hair disappears. Next, we need to add our groom. To do this, we need to mark the head so that the groom is immediately in the head hierarchy. Then, click the Add button, and in the search, find Groom. We rename it, for example, to Groom Export. Now, in the Groom Asset tab, we find the hair we imported, and it appears on the head. But they are not attached yet, and when Oscar moves his head, the hair will stay in place. Therefore, in the Binding Asset tab, we find the binding we created earlier. We can simply select it and click the Add button. We compile our MetaHuman Oscar. That's it. We open the Oscar level and see that Oscar now has a new hairstyle. To check how it behaves in animation, I create a new level sequence. I name it. I think it's better to create an empty level so we can set up the lighting as well. Right-click in the empty space in the content browser and find the level icon. We rename it. I save everything and open it. Now I open the sequencer. I position it a bit more conveniently. Now, I simply take the MetaHuman Oscar and drag him into the sequencer. Oscar is positioned in the middle of the scene, but we have no lighting. I go to Light, Point Light, and add a regular light. I adjust its position. I turn off Snap to allow free movement. And here is our Oscar with a mohawk. We can also see the rig controllers. I want to enable ray tracing for shadows on the point light. In the search bar, I type ray, and in the Cast Ray Tracing Reflection menu, I select Enabled. Also, to make the shadows less sharp, I increase the source radius. To set up stable light correction, I add a post-process volume. And in the settings, I check the Infinite Extent box. This way, the influence of this volume will spread across the entire scene. Now I can activate the exposure and adjust it. In the metering mode, I set it to manual and adjust the exposure compensation. Perfect. Now I can try moving Oscar's head to check how the hair will behave. Great, the hair is firmly attached to his head. But it would be nice to have dynamics in the hair as well. We can enable this in the hair properties. For this, we find our hair and open its settings. Here we can adjust what kind of shadows will be used on the hair. Also, the strength of the shadows. And we can adjust the hair thickness. Sometimes it's also worth reducing the hair scale type. But usually, if we export our hair from Maya, the thinning of the hair towards the ends is inherited by Unreal Engine. And for the hair to have dynamics, in the Physics menu, we enable Simulation. And we immediately see that our hair comes to life. Of course, there are many more settings in the Dynamics options, but in this tutorial, I'm showing only the main principle. We close the window and check the result. Now, when the head turns, the hair has dynamics, and they look more realistic. Essentially, that's the whole tutorial, showing how to transfer hair from Maya to Unreal Engine and change the MetaHuman's hairstyle. As a bonus, let's also look at how we can create a material and color the hair. So, in the content browser, we right-click and create a material. We name it Oscar Hair. We open the hair, and in the Material tab, in the Material slots, we click the plus to add a new material. In Element 0, we find the material we created. Now we open the material to adjust it. To make it a hair material, we need to do two things. First, select Hair in the shading mode. And second, activate Used with Hair Strands. We save the material. Now it's a hair material. To color the hair, and specifically to make the hair take the color of the texture, which uses the UV coordinates of the model on which we created the hair in Maya, we need to import the texture. I've prepared this color texture to better see how the color is distributed. We open the material and drag the texture into the material editor. We can't just connect it to the color slot. We need to use hair attributes. We find and open them. We connect the root UV to the UVs of our texture. And now, the RGB output of the texture goes to the base color input of the material. That's it. We save it, and now we see that our hair has taken the color of the texture, just as we wanted. Now let's create settings for the hair's shine. By pressing the number 1 key and clicking the mouse in an empty space, we can create a value. We connect this value to the specular. In the same way, we create another value and connect it to roughness. However, it's not convenient to keep opening the material and adjusting it in the material editor. We can create a material instance where we can simply change values without going into the material editor. For this, the values we want to change on the fly, we need to designate them as parameters. I right-click on the texture and choose Convert to Parameter. I name this parameter accordingly. I also create a parameter for the specular and roughness. I save it. Now, by right-clicking on the material, I click Create Material Instance. And I replace the material that we previously added to our hair. I save it. Now, by entering the material instance, I can activate the texture and have the ability to change it at any moment by simply dragging a different texture into this slot. I can also see our parameters for roughness and specular, which I can activate and control in real time. Let's set up the shine for the hair. A simple hair material is ready. Although, in this case, the hair is painted with one color along the entire length of each strand. That is, the base and tip of each hair have the same color. In most cases, this is enough. But sometimes you want to add a little variety to the hair color. For example, making the base of the hair darker and the tips lighter. How to do this? I'll save the project. Now, let's go to the material editor of the main material. By left-clicking in an empty space while holding the number 3, we create the color that we'll use for painting the root of the hair. Now, by left-clicking and pressing the letter L, we create a lerp. It consists of 2 inputs and an alpha, which is the transition strength between A and B. We add the root color to input A and our texture to input B. Now we create 2 value nodes, as I mentioned earlier. We convert them into parameters and name one, for example, amount, and the other power. We find the power node and connect the two nodes we created to it. Next, the output from the power node connects to a multiply node. And in the hair attributes, the length connects to the input B on the multiply node. Then, the output from the multiply node connects to the alpha of the lerp. The output from the lerp then connects to the base color of our hair material. We save it. We open the material instance and activate the parameters we created. Specifically, the amount parameter. Our hair has taken the color of the texture, and the base of the hair has the color we defined. Also, with the power parameter, we can shift the base color from the root to the tips of the hair. What else we can do is convert the root color into a parameter, so we can adjust it from the material instance. I'll name it color base. This is the result we get. Quite nice, I'd say. And as you can see, we can change the base color right here, without going into the material editor. This concludes the lesson. I hope you didn't get tired, and that what you learned was useful. I'm looking forward to seeing you in the next videos. To not miss them, subscribe to my channel and leave a like to motivate me to create more videos.